Hello, everyone. In the previous lessons, we have already learned about probe configuration and calibration, part clamping and alignment, and coordinate system establishment. These are all essential basic steps in precise measurement. Today, we will continue with a deeper exploration using the injection molding demo part as an example, specifically focusing on manual measurement steps. Next, we will study the following contents. Through this lesson, we hope you will be able to accurately identify and name the measurement features on the injection molding demo part, determine the measurement angles and sequence based on drawing requirements, independently perform manual measurements of the demo part, and accurately record and analyze the measurement results. First, let's look at the first part. According to the drawing requirements, there are 12 dimensions to be evaluated on the demo part. Before performing the measurements, we need to name the associated measurement features of these 12 dimensions in the prescribed format. Then, based on the respective planes of the features, we determine the measurement angles to be used during the measurement. The measurement sequence is determined by the measurement angle. Next, let's specifically study the measurement of these 12-dimensional correlation features. Once the coordinate system is established, we can proceed with the feature measurements. Now, let's proceed with the measurement of the features, following their distribution. The first dimension is the distance between planes, with associated features being reference plane C and plane 1. Next, use the probe to collect 4 points on each of the 2 planes. Generate measurement commands for plane 2 and plane 3, and rename them as PLN-C and PLN-1. The second dimension is the diameter, with the associated feature being the collection of 12 points, 3 layers, 4 points per layer, on optical reference hole 1. After probing, the measurement command for cylinder 1 is obtained, and it is renamed CYL1. The third dimension is positional tolerance, with associated features being 4 circles and reference planes A, B, and C. Since reference planes A and C are already defined, next, use the probe to collect 4 points on each of the 4 circles and reference plane B. After probing, the measurement commands for 4 circles and 1 plane are obtained, and they are renamed CIR1, CIR2, CIR3, CIR4, and PLNB. The fourth dimension is perpendicularity, with the associated feature being optical reference hole 1 and reference plane A. Since these measurements have already been completed, simply select them during evaluation. The fifth dimension is cylindricity, with the associated feature being optical reference hole 1. Since these measurements have already been completed, simply select them during evaluation. The sixth dimension is concentricity, with associated features being optical reference hole 1 and optical reference hole 2. Optical reference hole 1 has already been probed, so next, use the probe to collect 12 points, 3 layers, 4 points per layer, on optical reference hole 2. After probing, generate the cylindrical measurement command and rename it CYL2. The seventh dimension is flatness, with the associated feature being reference plane A. Since these measurements have already been completed, simply select them during evaluation. The eighth dimension is parallelism, with the associated features being plane 2 and reference plane C. Reference plane C has already been probed. Next, use the probe to collect 4 points on plane 2. After probing, generate the plane measurement command and rename it PLN2. The ninth dimension is radial runout, with associated features being optical reference hole 1 and reference plane D. Optical reference hole 1 has already been probed. Next, use the probe to collect points on plane 3. After probing, generate the plane measurement command. The 10th dimension is the sphere diameter, with the associated feature being sphere 1. Next, use the probe to collect 9 points, 3 layers, 3 points per layer, on sphere 1. After probing, generate the sphere measurement command and rename it SPH1. The 11th dimension is the angled hole, with the associated feature being optical reference hole 3. Before measurement, the probe angle needs to be switched to A45B90. Next, use the probe to collect 12 points, 3 layers, 4 points per layer, on optical reference hole 3. After probing, generate the cylindrical measurement command and rename it CYL3. The 12th dimension is the diameter, with the associated feature being circle 5. Before measurement, the probe angle needs to be switched to A90B180. Next, use the probe to collect 4 points on circle 5. In this lesson, we learned the manual measurement methods for typical features of the injection molding demo part, including the measurement of distance between planes, diameter, position tolerance, perpendicularity, cylindricity, concentricity, flatness, parallelism, roundness, sphere diameter, and angled holes. During the measurement process, we need to pay attention to the selection of probe angles, choose the working planes appropriately, and optimize the measurement path to improve efficiency and accuracy. I hope everyone can apply these knowledge in real-world scenarios and continue to improve your measurement skills. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next lesson.